Alright, so we're going to start the second set of questions 19 onwards. So let's go through this. So we have 5, this first question right here, which you guys can see, 5 plus 2 times 4 plus 3. Well, this is clearly PEMDAS. This is a column A, column B type question in which you have to determine which whether column A is greater or column B is greater, or C they're equal, or D none of the above. So you go through this, you're gonna have just regular old PEMDAS. So that's 7, and then you have 5 plus 2, right? Then you do here because that's the M in PEMDAS. So you have 14 plus 5, 19. And this is also 19. So C, they are equal. All right, pretty simple if you know your PEMDAS rules. So that's that one. Next one, number 20. All right, a bit more challenging, but definitely a doable problem. So we have x, 2x, y, 2y. We're dealing with the area and perimeter of two different rectangles, rectangle Q and rectangle R. So for rectangle Q, what I know is if I multiply x times 2x, I will get a total of 18 centimeters squared, or 18. All right, this is 18 centimeters squared. And then for rectangle R, I know that if I do y plus 2y, but I can't also forget there's a y here and 2y here, but plus y plus 2y, I will get a total of 30 centimeters. So if I do x times 2x, you guys learned your exponent rules, so this will be 2x squared is equal to 18. All right, then I want to do inverse operations, divide by 2, x squared equals 9. And then I'm going to use inverse operations here. Something times itself gives me 9. So this is, right now it's to the power of 2. So to reverse that, or the inverse of that, is the square root. So we get x is equal to 3. It could actually be 3 or negative 3. But you can't have a negative side, right? Because negative 3 times negative 3 is also 9. But in this case, you cannot, or in any case, you can't have a negative side. So you know it has to be a positive 3. All right. And then in this, on rectangle R, you have y plus 2y plus y plus 2y. That's going to give me 6y equaling 30. Now how I do this is just inverse operations, and I get y equals 5. So x is 3, y is 5. They're asking you what's bigger, x or y. Well, y is clearly the bigger option there because it's 5 versus 3. All right, moving on. We have 21. 21 is a much more challenging problem, but we did do a very similar problem in the last video, which was question 5. All right, if you knew how to do question 5, you can do question 21. Once again, this is going to be multiplying polynomials. So we go through it. First thing we're going to do is pretend like this y is not there. Okay, it's going to be and you're going to use essentially kind of like the distributive property and go through. So for a second, so first thing you do is have x go to every number like this. And I'm going to forget about this negative y for a second. We'll get to that later. All right, for that I'll have x to the third power, because remember this is x to the first. All right, plus x squared y plus x y squared. Okay, that's my x's. Now let's deal with the y's. All right, let's forget about, now it's time to forget about the x and deal with this y. So if it lets me erase. Okay, so this was, let's put this in blue, minus y. And for right now, we're going to forget about x. Remember, this is a negative 1y, all right? So what I'm going to have is minus x squared y, or you could have written as minus y x squared, which is the same thing as x squared y, minus x y squared, right? Because I have y to the first, y to the first. All right, so x y squared minus y to the third. Okay, now I can combine my like terms. Let me put this x back. Okay, so I have these two are this and this. It's a positive, that's a negative, they're the same thing. That can go. That's positive, that's negative. Let's use this. And it's positive 1, that's a negative 1. That can go. So now I'm just left with x to the third minus y to the third. And you see that between the two columns they're the same thing, so C, they are equal. This is a tougher problem because you do have to know how to multiply polynomials. So hopefully we have a better sense and understanding of that after this video. The famous parking meter question. I know we've gone over this a few times, but I will go over it again. There's a parking meter filled with $4.50 in dimes and quarters. Alright, and it contains twice as many dimes as it does quarter. Alright, so they want to know what's greater, value in quarters or $3. Okay, so how we would go about this problem is setting up an equation. Okay, so first you need to understand that we're dealing with two coins here, all right? So we're dealing with dimes and quarters, and each of them has a value, right? But we're trying to find the number of each type of coin. So let's call the number of each type of coin x, all right? But each of those coins have a value. So the value of a quarter, almost a nickel, the value of a quarter is 25 cents, and there's x of those. All right, well, the number of each type of coin is x, all right? And then I have the value of a dime is 10 cents, so 0.10 or 0.1x. We can leave it as 0.10. Now, I said x, but the number of each type of coin, that's almost a misnomer, right? Right, the number of quarters really should be x, because I know that there are twice as many dimes. So let's erase this. Number of quarters is x, right? And the number of dimes is 2x, right? And that's going to give me a total. Sorry, I'm frozen for the moment. Okay, I'm back. So that's going to give me a total of $4.50, right? Because I have the 25 cents times the x, which is the number of quarters, number of dimes equals 2x, right? Because there's twice as many dimes. 0.10 times 2x, total of 450. So I have 0.25x plus, now if I multiply this, I'm going to get 0.20x is equal to $4.50. I'll get 0.45x is equal to 450. If I use inverse operations, x is going to equal 10. So there's 10 quarters. So 10 quarters. If I wanted to find the value of the dimes, or how many dimes, there's 20 dimes. But that's not important for this problem. The value in quarters, so if there's 10 quarters and there's then I know the value in quarters is $2.50, which is less than $3. So B is my correct answer. All right, next one. Next one is very, very simple, but only if you know certain rules. So I'm going to teach you a very quick rule, and it's going to be very, very helpful. Okay, so line J is parallel. Line J is 3x plus 4. That means the equation of this line, of line J, 3x plus 4. That's the equation of that line. Now, line J is parallel to line K. So if I have line J being parallel to line K, one thing that a lot of teachers don't teach is the relationship of slope between parallel lines. Parallel lines have equal slopes. So if this is parallel, if J is 3x plus 4, then K, if this, right, because this is in y equals mx plus b form, where m is the slope, right, and b is the y-intercept. All right, so the slope of line J is 3. All right, that means the slope of line K, since it's parallel, is also going to be 3. So 3 is greater than negative 3. So your answer is A. All right, so you do need to have a little bit of background knowledge to do this problem, but once you have it, it becomes relatively simple because we know that the slopes are going to be equivalent. All right, I left the next page blank because I also wanted to teach you another trick, and that's go over slope of perpendicular lines. I think this is the spelling. So when you're dealing with slope of perpendicular lines, first let's review what perpendicular is. It's when two lines make a right angle. I know that's a really bad drawing, but they intersect making a right angle. Right? The slope of perpendicular lines will always be the negative reciprocal. So if I have y equals 4x plus 2, I know 4 is the slope and 2 is the y-intercept, of course. But now I need to start thinking to myself, well, if I asked for the slope of a perpendicular line to this, then I have the negative reciprocal. Alright, if I'm looking for the slope of a perpendicular line, and let's do that in green, I'll have y is equal to negative, well, right, and then 1/4 x. Now the y-intercept doesn't matter, right? I can make that, it doesn't matter. If I'm just asking for any perpendicular line, I can say y is equal to negative 1/4 x plus 0 or 2 or 5. It doesn't matter what the y-intercept is, but this does. The slope matters. All right, so now another question is, what if they told you the slope is negative, if I have negative 4x plus, or sorry, not negative 4x, negative 2x plus 4. And let's make this negative 2 over 3x, right? If I'm looking for the negative reciprocal, well, that means if I'm looking for a perpendicular line, that would be y is equal to, instead of negative, it would now be positive 3 over 2x, right? This 3 over 2 is now my slope of perpendicular line. Okay, so that one is done. Next question, 24. 24 asks you about perimeter of a rectangle being 50 inches. The area of the rectangle versus 144 inches squared. So if they tell you the perimeter is 50 inches, well, here's the thing. They say perimeter equals 50. They don't give you any other information. They don't even tell you that it's integers, right? So I could have decimals. So this could be, 12.5, or sorry, 12.5, 12.5, and then, because that's 25, or 12.5 and 12.5, right? This could be a square, for all I know, because a square is a type of rectangle. Or it could be 1, 1, that's 2, right? And then 24, 24. So that's, I have no idea what the dimensions are at all. So I can't really determine anything, so the answer is going to be D here. The answer cannot be determined from the information given. Okay. Next one. The area of the shaded region versus x squared minus xy minus y squared. Okay. This one seems tricky, but it's actually not too bad. Alright? So, if you're looking for the area of the shaded region, well, I know the area of the entire figure. The area of the entire figure is x squared, because I have x times x, right? And that would give me everything. But I'm not looking for the entire region. I'm looking for the shaded region. So I have to subtract non-shaded, which is y squared. So I have x squared minus y squared. So x squared minus y squared versus x squared minus xy minus y squared. Well, let's think about this. Normally, if they just gave me these two options without putting in the context of a shape, I would not be able to determine, right? Because what if x was negative, then this would become a positive number, which would throw things for a loop. But I know a side cannot be negative. We actually just went over that in a previous problem. So what I would do is I can assume that every number here is positive. So and they actually tell you that in the problem. X is greater than 0 and y is greater than 0. So they even are nice enough to tell you that information. So I can assume, since every number is positive, that I'm going to be taking something out in addition on this one. So I'm taking more things out. So I have x squared minus y squared versus x squared minus xy minus y squared. This is clearly going to be the smaller one because I'm taking out, let's just think about it logically. If I have I can plug in any positive number to make my case here, right? If I say, and I know x is bigger than y, right? So if I say, let's take simple numbers, 10 minus 10 squared minus 10, and let's make y 5. minus y squared, which is 5 squared, versus just 10 squared minus 5 squared. This is clearly going to be the larger number, right? So that's how you would go about that. Now, the 10 and the 5s were just examples. I just kind of chose those numbers out of thin air just because I wanted to prove a point. And you can do that when it benefits you with these types of questions. All right, number 26. The product of three consecutive integers is 210. The greatest of three consecutive integers versus 10. Okay, you could sit here and make an equation, or you could use the problem to help you out. All right, I know that this is a situation where I'm dealing with the biggest. I'm looking for which one's bigger, column A or column B. So if I know the greatest of three consecutive integers, all right, well, let's try this. 8, 9, and 10. Okay? Because in this situation, this is the greatest of three consecutive integers, and it can tell me if the answer is C, that they're both equal, or it could tell me if it's smaller or if it's bigger. So now I have 9 times 8, which is 72, times 10 equals 720. Well, this is just 210. So this, it's clearly, like, to get to 210, my three numbers have to be way smaller than 8, 9, and 10. So 10 is clearly the bigger number, right? Because I have to go down here, right? To get to 210, 720 is not 210, all right? To get to 210, I have to choose three smaller numbers, maybe 6, 7, 8, or 8, or 7, 8, 9. I don't know what they are. But I'm not going to waste time trying to find out what they are. I'm just going to move on to the next problem because I know that this is the bigger value. All right, next one. Okay, so I have 25n minus 1 versus 25 parentheses n minus 1, and I'm closing the parentheses. So what I would do first is I would do 25n minus 1 versus, I would distribute this, and I'd get 25n minus 25. And then you say to yourself, well, is there any number, any context, because off the top of my head, A clearly looks like it's going to be the bigger number. Well, I say to myself, is there any number or any situation in which that's not the case? If I plug in a negative number, well, it's still going to be a negative and a negative, which is a negative. Sorry, a negative and a positive, which is going to be a negative. So this is still going to be bigger. A positive number, well, is obvious. It's going to be bigger. That A is going to be bigger. 0, well, I can plug in 0. 25 times 0 is 0. 0 minus 1 is negative 1. And 25 times 0 is 0 minus 25 is negative 25. So positive, negative, 0, no matter what, I get that A is bigger. All right, so the next one. Now, I didn't write this in here, and I'm going to write this in here now, is that figures not drawn to scale. Okay, so in this case, even though they look like one might be bigger than the other, it's not drawn to scale. That means that I just can't look at it and see which is bigger and which is smaller. So the perimeter of square A versus the perimeter of rectangle B. So if I do this out, I know this has to be 0.75x because this is square of 0.75x. And then here I'm going to have y, and this is 0.5y. Now I'm going to do this. If I do this perimeter of the square, I add 0.75 plus 0.75, and these all have x, plus 0.75x plus 0.75x, and I get 3x Here, I'm going to get y plus 0.5y plus 0.5y, and I'm going to get 1, 2, that's 3y. 3x and 3y. Now, most people seeing that are going to say, hey, this is c, right? They're equal. But I cannot say that. I have no context of what x is or what y is. X could be 500 and y could be 2. Then I definitely know that they're not equal. They could be equal. I don't know. And because of that uncertainty, the answer is D. All right? 29. So 6-sided number cube, 1 to 6. Number cube is the same thing as a die or a dice. All right? And a coin is tossed. So they're asking probability. Okay, so sorry. Column A versus column B. Number less than 3 is rolled. Oh, this is a trick question. Probability of coin landing tails. I'm going to make sure I write this exactly. It's the probability landing tails up. Odd if. Alright, if an odd number is rolled, the probability of the coin landing heads up. So most people, when they see this problem, they see, wow, this is a very simple problem. And they don't read it. It actually is a very simple problem, but not for the reasons people think. So most people see it, they say, well, I have a number less than 3, so that's 2. And then they really focus in on this first part. All right, number less than 3, so that's 2 and that's 1. So they say 2/6 times, and then they say, and then the probability of a coin landing tails up. Well, what's the probability of a coin landing tails up? 1/2. So they do 2/6 times 1/2. They say the odd number is 3/6. All right, and then a coin landing heads up. Well, what's the probability of that happening? 1/2. Right, but notice it does not say and then. It simply says the probability, and that's why I wanted to write this exactly, or as close to exact as possible. It just says the probability of the coin landing tails up. Well, if I'm just asking about the probability of the coin landing tails up, the number less than 3 being rolled has nothing to do with it because it's an independent event. The one has no bearing on the other. This is also an independent event. The one has no bearing on the other. It doesn't say, and then, what's the probability of rolling a 3 or a number less than 3, and then the probability of a coin landing tails up. It just simply asks, if a number less than 3 is rolled, what's the probability of a coin landing tails up? That's like saying, if Mr. Arya runs a mile, what's the probability of a coin landing tails up? There's no connection between the two. All right? So 1/2 is the chances of it landing on tails. 1/2 is the chances of it landing on heads. So your answer is 1/2, which means they're equal to each other. Right? The probabilities end up being equivalent to one another. All right, next question. Only a few more to go. Median score. Okay, so we have a histogram. Our histogram is just very similar to a bar graph, but so we were talking about ranges. This little squiggly line here wasn't me messing up a drawing. It was me. It shows there's a distance between 0. Right, I should have written 0. And the first number, right? Because we don't want to write because we didn't want to write just zeros for 10, 20, 30, 40, 50, and or 10, 20, 30, and 40. Our first real action happens at 51 to 60. So let's go through this. So the exam scores were 51 to 60, and this side, so this is exam scores, and this side is number of students. All right, so now we have all right, so I know, like, so how I can read this is if there's 51, one person got a 51 to 60. If I'm looking at the 71 to 80 range, 4 kids got 71 to 80. So the histogram shows the exam scores of the students in the math class. So the median score versus the range. Okay. Now, since the histogram, it's going to give me not just one score. I don't know what the scores are for. It says one person got in between 51 to 60. He could have gotten a 51. He could have gotten 52, 53. It doesn't tell me. It just tells me a range of scores. But the range overall, it can be between. I know that the range is going to be between two numbers, and that is, well, the biggest range it can be is 100 minus 51, which would be 49. And the smallest range it can be is, and that's because that's the highest number, the highest possible number. Like Johnny could have gotten 100 and Billy could have gotten a 51, and then that's 49. All right, or it could be Johnny could have gotten a 91 and Billy could have gotten a 60, right? And that would give me the highest the lowest possible range, which would be 31. So it's between 31 and 49. I do know that. So, and the median score. Well, the median score happens somewhere between 71 and 80. I don't need to know the exact number, but I know it's going to happen somewhere there. I don't need to write out anything, but this one, I can see that it's going to happen somewhere in this area, right? Because there's a lot of stuff concentrated here. So, but even if I didn't know that, right? If I didn't know that, I could just see the lowest possible score is a 51. The highest possible range is a 49. So the median score has to be larger. So your answer is A. All right, I have 2 problems left. Okay, 5 candies, 2 orange, 3 green, 1 selected at random and replaced, then a second candy is selected. The probability of they're both green, the probability of the first candy is green. This one is simple. You can actually just look at it and tell that the answer will be B, but and the right way you're able to tell that is because the chances, and you can just think about in terms of common sense, right? If I take a candy out, right, the chances of it being green and then green again are going to be lower than of just selecting green once. But we can go through the problem and see. All right, so the probability of them both being green, okay? Well, the probability of it being green, so it's 2, let's do this in green then. 2 out of 5, right? So when I first do it, there's a 2 out of 5 chance that it'll be green, right? I take a candy out, right? And then I don't leave it out. So normally what would happen if it's not replaced, it would be 2 out of 4 and then times 1 out of 5, right? 2 out of 5 times 1 out of 4, because there's now 4 candies left, all right? But now I did replace it. I put it back in, all right? I didn't eat the candy. I put the candy right back in. So there's still a 2 out of 5 chance that I get it. So my chances of getting green and then green is 4 out of 25. Well, versus a chance of getting probability of the first being green, 2 out of 5 or 4 out of 25. If I just look at these fractions, 2 out of 5 is clearly the larger. If you need to double check, you can make a common denominator. That's times 5. That's times 5. So I have a 10 out of 25 chance of getting green candy on the first try versus a 4 out of 25 chance of getting green than green. All right. Save one of the harder problems for last. In February, apples are $1.50 a pound. In March, the price of the apples were 10% higher than in the February price. In April, the price of apples was 10% lower than the March price. So they want to know A, the price of apples in April. So price in April versus B, $1.50. So most people look at this and just say, well, they're going to be equal because it's 10% up, 10% down. That's not how it works. All right. How you would go about this is, first I'm going to determine the price of the apples in March. All right. You can do this via proportion. I'm going to do this via decimals because it's a little bit easier. If it's 10% higher, right, I know that 1 in terms of decimals is equal, the same way 0.9 is equal to 90%, 1 is equal to 100%. But it's 10% higher, so it's going to be 1.10. That's 110%. Okay? So now I have $1.50 times 1.10. And that, if I do my math out, is going to be, I believe, 1.65. But let me just double check. 1.5 times 1.15. Oh yeah, duh. That's going to be 1.65 because 15 times 11 is 165. All right, so 1.65. All right, that's the price in March. But I didn't ask about the price in March. I asked for the price in April. Well, the price in April is going to be 10% lower than my March price. Well, now this is no longer 10% of the value. Now my March price is the main price that I'm dealing with. This is now 100% of the value of March. So now I'm talking about April. So April's price is $1.65, but it is 100% minus 10%, which is now 90%. It is 90% of the price. So April's price is 0.90. 165 times 0.9 times 0.9. So if I do this math out, that's 5.4. I believe it's going to be 1.475, but let me just double check. 63 plus 4, 7. All right. 6. 9 times 1 is... Sorry, this is not 54. This is... Oh, whoops, that's a simple mistake. 59 times 6 is 54, plus 4 is 8, and 9 times 1 is 9. That's 9 times 1 is 9, plus 6 is 158. All right, now let me just double check I did my math right here. Okay, I made a simple error somewhere. Oh, yeah, I see where it is. I just multiplied wrong, which is kind of embarrassing, but let's do this multiplication problem again. We have 1.65 times 0.9, so that's going to be, that's 9 times 5 is 45. 9 times 6, which is 54, which is 8. 54 plus 4 is just, so I could take that, and then 9 times 1 is 9, so I have 1,485. I move it over 3. Now I have 1.485. Now normally you would round, but in this case I want to be as exact as possible. This is $1.48, but it's also $1.48.5, which I know is less than $1.50. So $1.50, and this is the price in April. Alright, so I know that $1.50 is my correct answer. Is my higher answer. So I'm going to highlight that. Alright, that's this. That was question 32. So that one's done as well.